Today, I'm going to talk to you about STP, Standard Temperature and Pressure. We've been discussing different gas laws, and as you can probably see in all of them, we have to deal with temperature and pressure. So to try to simplify things, chemists have come up with a term called STP, which stands for Standard Temperature and Pressure. And you might sometimes see this when you read different chemistry problems. So I want to explain to you what it means. Standard temperature and pressure is just a temperature and pressure that's been agreed upon to be the standard. Standard temperature is 0 degrees Celsius, which is the same thing as 273.15 K, and standard pressure is 1 atmosphere, which is equivalent to 101.325 kilopascals or 760 millimeters of mercury. I like to work my problems in atmospheres, so that is probably the one you'll see me use the most. Okay, now how might you see the term STP used? Here is an example of a problem. What is the volume of 5 moles of an ideal gas at STP? Well, we can look at our reference sheet and we know that the standard temperature is 0 degrees Celsius, standard pressure is 1 atmosphere. I have also included this information on your reference sheet that I give you for all of your exams. Right here I've got a blown up section of the gas law section. You'll see on the right here I have written down STP equals 0 degrees Celsius and 1 atmosphere. So you don't have to memorize those values, but you need to know what they mean and know how to use them. Okay, so now here we are back at our problem. What is the volume of 5 moles of an ideal gas at STP? We will go ahead and use our same ideal gas equation, PV equals nRT. We're solving for volume, so I'm going to isolate volume by itself. We're going to divide both sides by P. Volume will equal N times R times T divided by P. Now we can substitute in all of our numbers. N is 5 moles. That was given to us in our equation. R, again, we can look up on our reference sheet. We are going to use an R value of 0.082058 because we're going to use our pressure in atmospheres. And our temperature, again, we know our temperature because it's standard temperature and pressure. We are going to write down 273.15 Kelvin because we always need to use Kelvin temperatures in gas law problems, divided by P, which is 1 atmosphere. Okay, now we've set up our problem. And you know what? I'm going to go ahead and write in my units for my R value here. The units are liters, atmospheres per K mole. So our moles are going to cancel out, our kelvins are going to cancel out, our atmospheres will cancel out. So now we can get out our trusty calculator and complete our math. 5 times 0.082058 times 273.15 divided by 1 equals 112.07 liters. And now we can go ahead and round our answer. Because we started with 2 significant figures, we should really round our final answer to 2 significant figures. So I'm going to round this to 110 liters.